Hey everybody! We started our training on database last week, and this first module we are talking about data modeling. Well, while a lot of people think it's not important, a bad data modeling can cause a lot of troubles. And I have a challenge for you today. Okay, let me show what I have here. So here I have this model. It's a very simple model where we have a table Q, a table item, Q item, that's the item of the Q as the name implies, and we have a type of the item of the Q. So actually we are interested only on this table Q item here. So we have here the Q item ID. So it's the ID of the item itself. We have the type, we have the ID of the queue. We have a column that says if it's active or not. And we have a parent. Every ID can have a parent, so it has some sort of dependence. And we have the value, right? So I'm gonna show you here on my database how they are the representation of them. So if I have here the TQ item, this is the table on my database, right? So we have the QID, item type, item ID, it's active. So the type, as we see here, most of them are a big int. The integer are of 8 bytes, a small int of 2 bytes. Then we have another big integer, 1 boolean, that's 1 byte, another big integer, and a floating point here that's usually around 7 to 8 bytes, depends as I'm using numeric here. It will depends on the precision, but we can consider around 8 bytes. So we have 1, 2, 3, 4 columns of 8 bytes. So it's 32 plus 2, 36, and 1, 39, right? So 40 bytes, the size here. And I have 1 million rows, if we count. So from TQ item. So I have here 1 million rows. And we can take a look on this. So I like to actually take a look on the data folder, the file itself. So let's check the data folder. Base. I need to get the OID of my database. So this is the data dir, and this is my database test. So I have a lot of other tables here, not only that one, but we can get that one here. Yeah, let's get this one here. Okay, this is my table, right? So if I check here, I will see that my table has 74 megabytes, and it doesn't match, because, well, 1 million rows, if it's 40 bytes, I'm expecting to have 40 megabytes, or, well, that we have the headers and of the pages and some empty space. I would suppose I would be expecting to have around 50, 55, 60 something megabytes, right? With the data size. Let's put like, yeah, around 60 megabytes. And it's not the case. And even if I do a select here, if I ask my database, I can ask my database here, what is the size of that table. Like, for example, I have a query here. Just a second. Yeah, this is the one. Yeah, well, you see it's exactly the very same size that we have there. But one interesting thing is, if I reorganize that table, let's say I'm gonna create the very same table using a select. See, it's just a create table, as I just call it TQ item good, and I'm using a select and selecting all the rows from TQ item. So I'm just copying the very same table. So I have the very same 1 million rows. Well, we can believe the database here, but like, let's just do this, right? And I have 1 million rows, and the structure are very much the same from the both tables. So we have 1, 2, 3 big integers, as we have here 1, 2, 3, and then here I have a small integer, here one small integer, then I have a boolean and a numeric. So I have a boolean and a numeric. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 columns. So they're exactly the same table. Nothing has changed from one table to another one, right? And this nullable here, it's pretty much doesn't mean anything. We can even change the here, but it doesn't do much of a difference from the size. But like if I check here now, where is the size of those tables, we're gonna see that one table has 73 megabytes and another table has 65 megabytes. And it's quite a difference, right? So it's around 15, 20, yeah, 15% smaller. This table is smaller than this one. And if I have more data, as the more data I have, the larger gonna be the difference in size of those two tables. And my question for you is why I have this difference? Why just changing the order of the columns here makes one table at least 10 or 15% larger than the other table? The second question is, what is the impact of this difference in the data size on my database, right? And remember, my talk on Percona Live would be about reducing costs and improving performance with data modeling in Postgres. And yes, it's very, very important to understand how those work internally. So we're gonna talk about that on the database side, on the post. I'm gonna show you how those things work inside of the database, how the database organize the data files and how we can find the difference. And also during our training here that we're having online, this is another topic that we're gonna have. So after the training, we'll be able to understand how that works and how the database, how this data modeling thing can have this huge impact on here. We're talking about the size of the table. The size of the table, we see that it can have a lot of impact. I'm not going to tell you what is the impact because that's my second question. So the first question of this challenge is why? Why do I have that difference? Why one table is like larger than the other one, even though they hold the same data, even though they hold the same columns, and the only thing that I changed was the order of the columns. Aren't they supposed to be the same? And the second question for this challenge is, does it make any difference on the database? And I'm talking about performance because, well, I have a spoiler, right? So I'm talking about reducing costs. So that's a spoiler. So yeah, it does make difference on the cost. But how about performance? Does it make a difference? Well, I'm waiting for your answer. Have a great day and see you on the next class. Bye.